In this video, we shall talk about the next fundamental concept of relational databases. This is referential integrity. The idea behind referential integrity is that no referencing tuple in child relation allowed to exist if the corresponding reference tuple in parent relation doesn't also exist. Here is a little example. We can see the parent relation, the child relation, this is the foreign key that referencing this primary key, and we can see that these numbers exist here. These numbers exist here. But if we wanna add null value here, the DBMS will check if nulls are allowed on this column. If yes, then it's okay, we can insert null here. But no matter how we try, in no case DBMS will allow us to insert such a value here that does not exist here. Let's look at a quick demo. Here is our child relation, parent relation, and we will try to insert several records here and see what will happen. Let's start with checking what's right here in our tables room and computer. Here is the contents of room table, and here is what inside computer table. Then we will try to add two records into this table. First of all, we shall try to add a record with null in the foreign key. As we remember, the C room column allows insertion of nulls. So when we execute this query, as we can see, everything's okay. We may check. Okay, this computer was successfully added. And then we will try to add another computer referencing some room of 999 primary key value. Let's check. There is no such value in the primary key of the parent table. Sure, there is no. When we try to execute that query, we are getting error, and that record was not inserted because otherwise it would violate referential integrity. We've just talked about operations with child relation. But what if we perform some operations on parent relation? What if we try to delete, for instance, this row that we see has corresponding rows here? Or what if we want to change this number to this number and we see that this number is here? What will happen? This situation is controlled by so-called cascade operations, and the first is on delete cascade. When we try to delete a record from the parent table, all corresponding records from the child table are also deleted. Here is an example from a subject matter. Imagine a news site with a rule. If you delete a news rubric, all corresponding news should be also deleted. This is how it looks like. If we delete a record from the parent table, all corresponding records from the child table should be also deleted. And this operation is supported by all DBMSs. You should only select this onDelete cascade when you create a relationship between relations. The next operation is onUpdate cascade. It's when you update a primary key value in a record in the parent table, all corresponding foreign key values of all records in the child table are also updated. And here is an example. Imagine that we have employees and payments, and those are connected through passport ID, and that ID changes for some employee. All corresponding payments should be updated with their corresponding field. This is how it looks like. Parent relation, child relation, we update this value to some new, so the DBMS should find all those old values and also update them to some new value. And this operation is supported by most DBMSs. If your DBMS does not support such operation, you may use triggers. We shall discuss them later to emulate such operation. The next operation is setting nulls on deletion. It's when you delete a record from the parent table, foreign key values of all corresponding records from the child table are set to null. And here's some example. Imagine that we terminate some lease agreement, deleting the information about the tenant, so all rooms should become vacant, so their foreign keys should be set to null. This is how it looks like. If we, for instance, deleting these records, the DBMS should find all those values and set them to null. This operation also supported by most DBMSs, or you may use triggers to emulate that operation in case your DBMS does not support such operation. The next operation is setting some default value on deletion. It's when you delete a record from the parent table, foreign key values of all corresponding records from the child table should be changed to some default value. And here is a little example. For instance, we dismiss a call center employee, so all phone numbers previously assigned to this employee should be temporarily transferred to the department head. This is how it looks like. When we delete some record here, the DBMS should find all those values, then the DBMS should somehow find out this new value and change that old value to this new value. This operation is not supported by any DBMSs by default, so you should implement this using triggers. Why is it not supported by any DBMSs? Because a DBMS should know the way how to detect that default value. So you should usually find out those default values using triggers. The next approach is to restrict delete or update operations. So, when you delete a record from the parent table or update the primary key of a record of a parent table, the operation is prohibited if there is any corresponding record in the child table. For instance, in some online store, one cannot delete a product category if at least one product is assigned to it. This is how it looks like. If we, for instance, trying to delete or update to some new value the primary key of the parent table, the DBMS should check, and if at least one record is assigned to this record, that operation should be blocked. This approach is supported by any DBMSs, and we absolutely should mention that no action or restrict is the same, depending on the SQL dialect you are using in your DBMS. And here are some important facts about cascade operations. First of all, cascade operations are activated by modifying parent table only, never by modifying a child table, so parent table only. The second, cascade operations are activated if only primary key is affected. For instance, if you have a table, this is primary key, these are some other fields, and you modify values in those other fields, but you do not modify primary key. So no cascade update or something like that will happen. You should modify the primary key, or you should delete the record. So when you delete the record, you are dealing with primary key, and that will activate some cascade operation. The next, data insertion and selection never activate any cascade operation, so just remember it. And some types of cascade operations should be implemented manually via triggers or some other approaches in many DBMSs. And of course, in most cases, cascade operations are mutually exclusive, so for instance, you cannot activate on delete cascade and on delete set null at the same time. You should choose either that or something like that. And also please remember that cascade operations are bad for DBMS performance. So when you're trying to link some relations, think carefully what primary key should you use. If you use natural primary key, a lot of cascade operations will happen and they will influence their performance drastically. They should decrease the performance. So maybe you should use surrogate primary keys. It will be better because it will allow you to avoid a lot of cascade operations and preserve the performance of your DBMS and your database. Cascade operations and referential integrity are just parts of the huge concept data consistency. So data consistency is a database property stating that a database should conform to all declared integrity constraints, such as relationship, data types, unique constraints, and so on and so on and so on. There may be a lot, hundreds of those constraints, but we shall review a little but very representative example. Imagine we have news rubrics and news, and we want for each rubric to find out the date time of the latest news publication. Of course, we may join those tables, we may somehow select that information, calculate it, and so on, but that will take a lot of time. So we may add such a column here, and we may copy those date times here. But how can we do that? No DBMS will allow you to do such a thing from the box. So you have to use something like trigger, usually trigger, to analyze the table, to watch the table, and once any news is added or deleted or updated, you should find that news, for instance, that would be this news, and you should update the information about that rubric in that field. And then you may only select this table. You need know this table anymore for selecting the information about the latest news. But before that, you should create a trigger and analyze that table and update these values constantly. So as you can see, triggers are extremely good, and we absolutely should discuss them later in our course, but in the next video we shall discuss indexes.